So here we've got quite a lot of information. We've got concentrated sulfuric acid as acting as a catalyst during the elimination of water from alcohols. We've got some examples of what we're using, and then it's asking us to draw the structure of another structural isomer of C5H11OH. That is a primary alcohol. So what I've done here, first of all, I've drawn out pentan 1-ol. So if you draw out pentan 1-ol, you can't have the marks because that is what we were starting with. It's asking us for an isomer of pentan 1-ol. Now the first thought would be, okay, let's move the OH. Let's move it to here or here or here. But if you do that, what you're creating is a secondary alcohol as opposed to a primary alcohol, and the question's asking us for a primary alcohol. You can't move it to here because if you do, all you are doing is drawing the same substance in a different format, because there it would be on carbon 1. Here, because the OH is at this end, we refer to this as carbon 1. So what we need to do is think about branching. So I haven't drawn the full structure here, just a bit to help you with your thinking. We start off with the OH on the end. It has to be attached to a carbon that is attached to 2 hydrogens and 1 R group, so one long chain. If it's attached to more than one R group, then it's not a primary alcohol. So here we've got the primary, we're keeping it as primary, and now you have to change the rest of the structure. So think branching. On the next carbon along, put in a branch. Once you've put in that branch, you've now got 1, 2, 3 carbons. You need to fill in with the rest of your carbons. So just go along from here and add in all of the remaining carbons. So we've got 1, 2, 3, and we need 5. So 1, 2, and then fill in with all of your hydrogens around the side. And that would be an example of one of the isomers that we could have. Equally, you could have your CH3 over here, or you could have 2 lots of CH3s. So a few different options, and you can find the alternatives in the mark scheme.